I've argued that 30 years of international negotiations on climate policy have not led to much in terms of emission reduction. Of course, a huge pile of paper was produced, huge cost incurred. And I've also argued that fortunately they've given up on the legally binding targets and timetables and replaced it, after much trying, with a more sensible pledge and review system. There are actually two international environmental agreements that were successful on acid rain and on the hole in the ozone layer. The question is, why were these successful? Because they did provide international, and in case of the ozone layer, even a global public good. So the question is, why did this work? And can we learn things about that for climate policy? So this is where we are. And I'm going to start with acid rain. So what is acid rain? It comes from the burning of coal and oil. And if you do that, there's always impurities in there, and sulfur and nitrogen is emitted into the atmosphere and deposited after a week or two. And because it's a week or two, these stuff gets blown all over the continent. Not so much all over the world, but definitely they can cross Europe depending on the strength of the wind and of course the direction of the wind. It's called acid rain because a lot of it is deposited when it rains, but it's actually also dry deposition. It also the acid also comes down when it doesn't rain. And the problem with acid deposition is that it kills trees, it kills fish, it damages buildings, particularly limestone buildings and monuments, and it reduces the visibility because there's stuff in the atmosphere that gets in the way. So it is a problem, or it used to be a problem in Europe, because the international response has been quite effective. What happened first was that there was an agreement between a relatively small number of Western European countries to cut emissions by 30%. And then later on the deal was expanded to include all European countries. And the target was much more stringent, 60%, and it shifted from emissions to depositions. And as part of the enlargement of the deal, different countries got different targets because they were in different circumstances. This is a more localized problem and much more locally differentiated problem. And the countries of Eastern Europe got technical and financial support in order to meet their targets. There is already a key difference here with climate policy, in the sense that they started with a small group of like-minded countries before going to try and cover the whole problem. Whereas in the climate negotiations, right from the very beginning, all countries were around the table. And then it's simply much harder to negotiate. As I said, this has been a success, so much of a success that it's actually hard to find an update of this graph. If you focus on the red line, you see that acid deposition steadily rose from 1850 to 1970 or so, and it has been coming down. Similarly, North America has solved this problem, but of course there you have a federal government who can do this. And it started falling in the 1970s, and this is important because at that time the European Union didn't have strong environmental teeth. So this really was a voluntary collaboration between sovereign states. You also see that if you focus on the green line, that the problem wasn't solved in the year 2000 in East Asia, and it actually gotten much worse since. South Asia is catching up with East Asia in terms of the problem getting worse. It's getting worse in Latin America, and it's getting worse in Africa even. So this is a problem that has been solved in the Western world, but not in the rest of the world. Now, why did this happen? Because the emissions from the UK blow to Germany and the Netherlands, and the emissions from France blow to Eastern Europe, and the emissions from the Czech Republic are scattered all over Central and Eastern Europe. So really it is an externality across sovereign nations. So how did they solve this? Well, there's 5 reasons listed here, and the first is that yes, it is true that acid rain is a continental externality, and reducing the emission of acidifying substances is a continental public good. But a large source of these emissions is from transport, and these particles do not just cause acid rain, they also cause local air pollution. And that means that you actually have a reason in your own self-interest, or at least within the self-interest of a jurisdiction, to solve this. And a lot of the measures that were taken to cut local air pollution just happen to also solve continental air pollution. So that is one reason. A second reason was that at this time power plants, electricity generation, was state-owned, and that was the other main source of acidifying emissions. So the policy was not a matter of the government trying to regulate private operators with all the problems that come with that, but it was really one part of the government telling another part of the government what to do. And then you had a cabinet or a prime minister or a president who could solve and who could override any objections of any of the parties. So that was part of the reason. The other part of the reason is that these were monopolies, and because they were monopolies, they were not sensitive to price, and they could just pass on the costs of reducing emissions to their customers without any concern for competition or anything. So that helped. Of course, when those utilities were privatized, they dropped burning coal, which was not economic, and replaced it by burning gas, which burns much cleaner. So that helped as well, and that's the fourth reason that is listed here. And this particularly accelerated after privatization. So when sort of the one reason was taken away for privatization, the other reason just happened to take over, and we switched rapidly from coal to gas. The third reason listed here, with the fourth that I mentioned, is that it's actually relatively simple to take acidifying substances out of the equation. And there was a very strong public demand to do something about this. People feared that all the trees were dying. That was the main concern in the public, particularly in Germany. There was great fear of the so-called Waldsterben, the dying of the forest, and people really demanded action. So there was a lot of public demand and therefore political support for these measures. Unfortunately, it is not that expensive to do so. So essentially what you need to do in a power plant is that you need to put a scrubber on your smokestack. So instead of emitting the CO2, emitting the sulfur into the atmosphere, you put your flue gas into a chemical plant, and that takes the sulfur out and then dumps the rest into the atmosphere. And yes, these things cost money, but they add perhaps 20, perhaps 30% to the price of electricity. So that given how strong the demand was not an excessive cost. Similarly for transport, what you need to do is essentially catalytic converters take out some of the substances, so that is something that costs £1,000 per car or something to put those things in. And you need to change your refining process so that there's fewer acidifying substances in the petrol or diesel that you stick in your car. So that adds to the cost, but again, it is a relatively small amount that you add to that. So it was a technical fix. You need not ask the people to stop driving cars. No, they just needed to put an extra piece of equipment in their car, and they did not do that themselves, of course. So you did not need to tell people to stop using electricity. No, you just needed to make electricity in a slightly more expensive way. So this is a technical fix that does not demand a change in behavior. It just imposes a relatively small cost. So that makes the problem relatively easy to solve. And the fifth reason, and it's listed last, but it was definitely not the least contribution to solving the problem. A lot of the heavy industry in Eastern Europe collapsed after the wall came down, and that was a major source of acidifying emissions, and that just had disappeared almost overnight. All these steel factories and chemical plants essentially shuttered, and their companies went bankrupt, and that greatly helped in solving the problem. So that is the story about acid rain. Really, to a large extent, the problem just disappeared for reasons other than acid rain policy. And the contribution of acid rain policy was really a technical fix at the end and not too high a cost. And these things do not necessarily carry over to climate. So let's turn to the hole in the ozone layer. Another problem, a global problem that has been successfully solved by an international environmental treaty, or so it seems. So what is the problem there? So some 10 kilometers above our heads there is this there's a high concentration of ozone, which is a good thing because it filters out UVB radiation. And because it has done so for a very long time, we and most other organisms have evolved in the absence of strong UVB radiation, and therefore we are completely not built to withstand that. And the problem with UVB radiation, or a high exposure to UVB radiation, is that it gives you cancer, and if you're smaller, then it can even change your DNA. So it's a huge problem for basically everything that lives, and that is in the sun. Now, that ozone layer has been there for a very long time, but what we've been doing is use so-called chlorofluorocarbons, CFCs, and these are substances that do not occur naturally. They're entirely human-made, invented in the 40s and the 50s, and they are brilliant as refrigerants. They're in your fridge, as solvents. They used to be in hairspray, as propellants, and so on and so forth. The solvents, they use them to make microchips and those sort of things, and they're absolutely brilliant chemically. And one of the reasons that they're so brilliant is because for a very long time these things were thought to be chemically inert. That is, they did not react to anything. And that is good, because if you use CFCs in, say, a fire extinguisher, you can stick the CFCs in the fire extinguisher, hang it up, not use it for 10 years, but then when the fire is there, it still works, so you don't need to replace it because it's chemically inert. Similarly, for the CFCs in your fridge, you can just leave it there. You don't need to take your fridge every month back to the shop to replace the coolant. No, the coolant just keeps working time and again for a very long time. Or if you have a spray can, you can just leave it on the shelf for a very long time. So CFCs were thought to be absolutely brilliant because they are chemically inert, and people really thought that they were always chemically inert. And because people thought that, at the end of their lives we just dumped them into the atmosphere because they were innocent gases. They did not react with anything. Not true, it turns out. If CFCs go high up in the atmosphere, they do react to the different radiation that is there, and they get into a catalytic process with ozone. And a catalytic process essentially means that the substance appears, it changes everything around it, but the substance itself doesn't disappear. And as a result, one atom of CFCs can destroy up to 100,000 atoms of ozone, and that caused the ozone layer to thin. It's not that there's a literal hole in there, it's just the ozone layer thins and leaves through more UVB radiation, which, as I said, causes cancer, changes DNA, and all sorts of other problems. The threat was recognized at the conference in Vienna in 1985. There was an agreement that essentially was very weak. Essentially, countries promised that they would cooperate and they would share information, but they could not agree on actually solving the problem. That changed only 3 years later, when 24 rich countries agreed to phase out production and consumption of CFCs over time at a very slow pace. And that Montreal Protocol has been amended 5 times, and each of the 5 amendments sort of made the protocol grow in scope, in the sense that new countries were added, and it also at the same time accelerated the targets. And in January 2001, consumption and production of CFCs was essentially forbidden. So this is a success story, and you can see that here. Emissions of ozone depleting substances went up until roughly the negotiation of the conclusion of the Montreal Protocol in 1988, and ever since they have been falling. So this is a success story of international environmental diplomacy, and the question is, why? How? And it's not just that the concentrations have, the emissions have come down, but with a lag, the concentrations of ozone high up in the atmosphere have gone up as well. So the hole in the ozone layer is closing, and projections are that by the middle of this century we're back to where we were before we started releasing all these CFCs. Now, why did this work in Montreal? And that's the top picture that you see there. Because it is a global public good. Part of the reason was a strong public demand for action, and that comes because UVB radiation causes cancer, and cancer scares people. Scares people perhaps more than what they would have because at one point the U.S. Environmental Protection Agency released a report that predicted that over the course of the century 100 million people would get skin cancer, and that got into the media as 100 million people will die each year, which truly scared people. It is not true at all. But there was a strong public demand to fix this because cancer is scary. And the demand here was not environmental but was health related. People cared about the health problems for themselves in the future, rather than for what it was doing to fish and plankton and those sort of things. There was another success, another element to this success story, and that is, as with acid rain, there was a cheap technological fix in the form of HFCs, hydrofluorocarbons. And the issue, or HFCs, slightly more expensive and slightly less desirable than CFCs, but works fine as coolants and solvents and propellants and what have you. So there was just a technical fix available that was only slightly more expensive. And this actually explains the results at Montreal. As with climate, these conferences take about 2 weeks, and the first week, actually the first week and a half of the negotiations in Montreal, there was the usual stuff going on, that people were lamenting the scale of the problem, and we were talking about all the horrible things that would happen if you don't solve it, and then the solution was always that somebody else should take the lead in solving this, and my country can obviously not be expected to do much because it would be way too expensive, right? So the typical things that you see at these international conferences about global public goods after you, sir. And that was the first 10 days of the Montreal negotiations. Nothing much happened, just polite waffle. And then something happened on the Wednesday night, and what happened on the Wednesday night was that the CEO of DuPont called the White House and said, look, Ron, we've solved the problem, now you negotiate us a sweet deal in Montreal. And that is what Ronald Reagan, who you see depicted here, did. So he received that phone call, faxed, this was in the olden days, faxed his negotiating team in Montreal, and overnight the US delegation changed their position. The Europeans and the Japanese were so flabbergasted by the American move that they just signed up without further analysis, without further thinking, without thinking through the strategic consequences of what they had just done. They just followed the American lead. The reason that DuPont did this is perhaps surprising, because DuPont, a major chemical company, was also a major producer of CFCs. And why would DuPont want to put a restriction on one of its products? The reason that the CEO said, look, Ron, we cracked it, is that they were the first to develop a substitute for CFCs, namely the HFCs that I mentioned before. And by introducing a ban of CFCs, DuPont acts in which all its European and Japanese competitors knew how to make. DuPont essentially negotiated a temporary monopoly on the supply of HFCs for itself, because nobody else at that time knew how to make it. And that is what really happened at Montreal. This was pure self-interest. This was a company trying to create a market for itself. When the Europeans and the Japanese returned home and it began to sink in what had really happened, European chemical companies like BASF, for instance, or the Japanese chemical companies were extremely cross with their governments, but by then it was too late. So that is what drove this particular problem. And then later on, the later amendments, how did they expand this treaty from 24 rich countries to essentially the world as a whole? Poorer countries were given financial support, they were given technical support, particularly this is particularly important for India, and other countries were simply threatened or bribed in another way. And for China, the choice was very simple, or the choice that was given to them was very simple. If China wanted to exceed the World Trade Organization, which it did want, it had to sign up to the Montreal Protocol, and that was essentially the bargain that was struck. If you want WTO, you have to take Montreal, and that is what China did. And as I said, the problem has been basically solved. This is what I show. These are the emissions, they have come down. There's still concern about illegal trade and illegal emissions, and that is the bottom picture that you see there. That is Korea, that you may recognize, in the southern half of Japan, and then of course further to the west lies China. And by now, satellites are good enough, the chemical sensors on for the physical sensors, because you can actually see this in the light that things emit. The sensors on satellites are now good enough that you can actually see these CFCs when they are emitted. And what a particularly irresponsible company in China, in the north, somewhere near Beijing, did was they, even though it's forbidden in China too, they just made CFCs and emitted them into the atmosphere. But fortunately we can now see these things with satellites, and as far as we know, this illegal source of emissions have now been closed. Still an issue with waste, because older fridges and so on and so forth still have CFCs in, and they need to be properly disposed of to make sure that the CFCs don't enter into the atmosphere, which is fine and under control in Europe, not so much in parts of Africa. So the problem is largely solved, but not completely. I did give you the reason why the Americans signed up to this, and the Europeans and the Japanese just stumbled after them. I told you why India signed up, essentially bribed with money and technology. Why China signed up was essentially the price to accede to the World Trade Organization. But another important part of the Montreal Protocol were trade sanctions, and that explains why a number of other countries signed up. So the Montreal Protocol has trade sanctions and essentially these are export bans, and export bans are perfectly legal under the World Trade Organization rules. You essentially say, I'm no longer gonna sell these things. Now these trade sanctions work for the following reasons. So anybody with a degree in chemical engineering would know how to make CFCs. They are not difficult to make, but the only way to make them cheaply is to make them in bulk. There's very substantial economies of scale. You want to make large amounts of them. So for small countries that do not have a domestic supply of CFCs, essentially the choice that they had was, sorry, I should have said that. The ban on the export of CFCs was a ban on the export of CFCs to non-signatories of the Montreal Protocol. So if you're a small country and you don't have your own chemical industry, if you do not sign up to the Montreal Protocol, you will no longer be able to buy CFCs. And because you're a small country, you can make them yourself, but it will be very expensive. Whereas if you sign up to the Montreal Protocol, you can actually continue to buy CFCs for a longer time, and any country can of course buy HFCs. So it is a simple calculation then. You either sign up and continue to buy CFCs for a shorter period of time but at a low price, or you almost immediately get bumped into a much more expensive domestic source of CFCs. So these export bans worked very effectively on small countries that did not have their indigenous supply of CFCs. The export bans were actually never implemented or enforced. It was the threat of the export ban that got a lot of countries to sign up. Now this obviously doesn't work for large countries, but as I said, China and India essentially got bribed into buying these things. So for the exporters of CFCs, this worked for a country like the US because the choice was essentially between an unrestricted market in CFCs, which anybody could make, and therefore the margins were pretty thin. But the good thing there, from a US perspective, was that it got a high value growth market, the HFCs, in return. And then of course there was also domestic pressure for emission reductions. The good thing about HFCs is that they do not destroy the ozone layer. The bad thing about CFCs is that they do not only destroy the ozone layer but also cause climate change. The bad thing about HFCs is that they're actually stronger greenhouse gases than CFCs. What has been happening in recent years is that the international treaties on substances that destroy the ozone layer have been used to regulate climate as well. And in Kigali a few years ago, bans on HFCs were announced. And essentially what people have been doing, they've sort of been looking at the climate policy arena and saying, well, nothing much is happening here, we can't expect much, but we do have a functioning ozone, international ozone regulation, and essentially what they've been doing is pushing these ozone regulations to solve part of the climate problem. The background here is that again by now there are technical substitutes for HFCs that work almost as well and only slightly more expensive, but do not cause climate change. And in the Kigali Amendment to the Montreal Protocol, there are now bans being introduced on the use of HFCs. Now, what can we learn about from these stories for climate policy? And sort of the headline is that yes, you can use international environmental negotiations and treaties and law to um, help solve an international environmental problem, to provide an international or a global public good. Um, Common among all three environmental problems is that there is a strong public demand to solve them. So that cannot explain the success of acid rain policy and ozone policy and the failure largely of climate policy. For both the acidifying gases and the ozone depleting gases, there was a cheap technical fix, relatively cheap technical fix. You could change this problem without wholesale changes in behavior, without imposing a large economic cost. You could fix this. What I forgot to say about the CFCs is that these are essentially niche applications in industry. Although most people use a fridge, they actually never go and screw it open and replace the coolant. So this is really stuff that is going on far, far away from most people and from most companies. This is something that a relatively small number of specialized companies do for us. Energy use is, of course, and therefore the CO2 emissions that come from energy use is something that we're all involved in. And the same is true for the emission of acidifying substances. Yes, we all use petrol, but taking the sulfur out of the petrol is not something that would require a change in behavior, or making electricity differently is not require a change in behavior. So in that sense, it was very much an effort that was focused on a relatively small number of companies that could take away the problem at a relatively minor cost. We're not there yet for climate. What definitely helped in acid rain policy is that emissions were also cut for other reasons: economic collapse, local air pollution, that do not seem to carry over that much to climate. Yes, there are instances where through climate policy you can also solve other environmental problems associated with energy, but there's also instances where the two actually are at loggerheads with one another, and acid rain is actually a good example of where they are at loggerheads, because those scrubbers that I talked about use energy and therefore emit more CO2. So you take out the sulfur from your flue gas, but as a result you emit more CO2. So that lesson carries over only to a very limited extent. And then the main reason that the emissions, or that Montreal was a success, was that one of the main suppliers of CFCs developed the alternative and thought, I can make more money selling HFCs than I can make selling CFCs. And that is a lesson that absolutely does not carry over to climate. Essentially what we're saying is we should stop buying oil from the Saudis and start buying solar power from the Saudis instead. And if the Saudis would make more money from selling solar power than from selling oil, they would be very happy, presumably, with that. Or we should stop buying coal from Australia and start importing wind power from Australia. But that is not what we're doing. A lot of the rhetoric about climate policy is to, yes, switch to renewables, but at the same time there's a strong rhetoric of switching from imported energy to domestic energy. And that, of course, is not at all in the interest of the current suppliers of fossil fuels that we make that switch, and therefore they are not particularly cooperative, let alone proactive, as DuPont was in solving this problem. And for those reasons, yes, the acid rain problem was a continental public problem a continental public bad in Europe, and it has been solved through the collaboration of sovereign countries. And yes, the hole in the ozone layer is a global public bad, and was solved through the voluntary collaboration of sovereign countries. But the particular circumstances and particular characteristics of these problems mean that these are useful lessons on why these things can work, but unfortunately the circumstances and the characteristics of the climate problem are very different, and there's very little we can really take over from these two problems, from acid rain and the hole in the ozone layer, and apply them to climate change.